We are going to do two more examples for work problem using ratio and proportion to solve. And like last time, we're going to do one with table and then one with proportion. So let's look at the first one. And if you need to pause the video and write down the question first. So when you're ready, we can look at it together. So this is a work problem. You have planted 84 orange trees and 25 apple trees. If you want to maintain a ratio of 7 orange trees for every 6 apple trees, how many more apple trees do you need? First, we're going to set a table and write down what we know. We did last time. And I would suggest you to use two different colors so you can write down what you know with one color and the things you figure out with another color. So orange trees and apple trees. They didn't ask for the total, so we don't really have to list the total. We know that we want to keep a ratio of what? 7 orange trees for every 6 apple trees. So 7 orange tree for every 6 apple trees, right? And why now you have planted 84 orange trees and then 25 apple trees. So probably it's not going to be 25 because they asked like how many more apple trees do you need, right? So very likely that 25 is not a number for the final answer, right? That's just what you have so far. We want to figure out how do we get from 7 to 84. You can try to multiply 7 times 1, 7 times 10 is 70. 7 times 11 sounds like 77, maybe 7 times 12. So I feel like it's 7 times 12. I'm going to need to check. 7 times 12 is 84. And if you cannot come up with that, you can try to use 84 divided by 7. You also get 12, right? So that's how I get that number. You can write yourself a note that think about using 84 divided by 7 equal to 12. So 7 times 12 will equal to 84, right? I can say, and I'm using a different color, 7 times 12 will get me to 84, and I'm going to do the same with my apple, right? Times 12, 6 times 12 is going to be 72. The total number of apple tree I need is 72, but I already have 25, right? So I would have to also calculate how many more apple trees. So I'm going to need to use total that I need, subtract the planted number, right? Totally, I need 72 apple trees, but I already planted 25 of them. So 72 subtracting 25 is 47 more, right? So I'm going to need 47 more apple trees. Is that okay? So that would be the answer. Because it's a work problem, so I'm going to need to write an answer statement. I'm going to say I need to plant 47 more apple trees to maintain the ratio, right? Okay, so that's how you use the table to solve it. And then they also ask us to solve by proportion. So remember proportion, first we need to write down what to what. So we have orange tree to apple tree. And the ratio according to them is 7 orange tree to every 6 apple tree, like that. And then now we know that we have 84 orange trees and 25 is not going to be enough, right? So I'm going to need to solve for how many apple tree total first. And last time we told you you can do cross multiply if you want to, or you can try to get rid of the denominator. It's pretty much the same process, but you will have 7 times A equal to 84 times 6 or 6 times 84. The order doesn't really matter. So I'm going to need to multiply 6 times 84 with 504 on this side. And this is 7a, right? And I'm solving for a, and 7 is multiplying to a. I need to do the opposite, which would be divisions for both sides. So after that, I should be able to solve a equal to, so this is 504, need to be divided by 7, which is 72 total for apple trees. And same thing, we will use the total that we need for apple tree, subtracted the number we planted to see how many more, right? So we have totally need 72, subtracting the 25 already planted, it would equal to 47 more, right? Apple trees. Say I need to plant 47 more apple trees to maintain the ratio. Okay, so hopefully that makes sense to you. When you're ready, I have one more example, and you can use them to guide you to do the homework problem. Right, ready? The last example for this, we have during rush hours, there are 4 empty seats to every full seats in various forms of transportation. If there are 2 million seats in total, how many of them are full during rush hour? So again, pause the video and write down the question, please. And when you're ready, we can work on this together. First, we need to set the table. It looks like the ratio is between empty seats and full seats, right? So I'm going to list empty seats and full seats. And the question suggests that 4 empty seats to every full seat, meaning the ratio is going to be 4 empty seats to every 1, because a lot of people drive themselves to work or something, right? So they don't have a passenger. And what else did they give us? They say there are 2 million seats in total. So we don't have the part say total, right? So I'm going to need to find the total. If we add these two together, we get 5, right? So we don't know this number. I'm using a different color. And I also were given there are 2 million total seats, right? So I'm going to put 2 millions here. Are we okay? When we get to here, I need to figure out 5 times what is 2 millions, or we can think of it as the division problem. We can start with 2 millions divided by 5, which is 400,000, right? I'm going to say we're going to think about 2 millions divided by 5, which equal to 400,000. The 5 multiply 400,000 should give me 2 millions, right? Multiplying 400,000, and we're going to need to do the same with the top 2 number. So the first one, 4 times 4 is going to be 16, and then we have 50. So that's 1.6 million, and 1 times 400,000 is just 400,000, okay? And what are they asking? How many of them are full during the rush hour? So full is going to be this guy, right? So the answer is this guy. So I'm going to answer the questions saying that there are 400,000 full seats during rush hour. Is that okay? That's how you use the table to solve this problem. And then we're going to need to use proportion. This one is slightly tricky. The last two work problem are a little bit more trickier, so you have to kind of think about it. You will think we do like empty seats to full seats because that's the ratio that they gave us, right? Which is 4 empty seats for every 1 full seat, right? But then we don't have a number given here. We don't know this number, we don't know this number, right? So we cannot quite use it like that. The number they gave us is the full seats. We will have to use the proportions of full seats to the total. And the way we found the total is going to be the full seats plus the empty seat, right? 1 full seat for 1 full seat plus 4 empty seat, right? Total is 5, right? Just like when we did the table parts. And then they also gave us that we have 2 millions total seats, right? So 2 millions here. And we don't know how many full seats, right? So that's how you set it up. So you have to be a little bit more careful with this one. This is going to be 1/5 equal to full seats over 2 millions. This is full seat over total, right? So again, to solve it, we do what again? We do the cross multiply like this. Actually, write that out for me. And that means 1 need to multiply to 2 millions, which is just 2 millions, right? Equal to 5 times f. To solve for f, we just need to divide both sides with 5, right? Because it's multiplying together, 5 and f. The opposite would be divisions. We divide 5 both sides. Cancel out, so f will equal to 400,000, just like what we found earlier. And then we can answer that there are 400,000 full seats during rush hour. Are we okay?